Alright, if we do have a right triangle, we know this angle measure is 90 degrees. The three angles inside of a triangle have to add up to be 180 degrees. So that leaves 90 degrees for these two angles here, A and B. So A plus B must be equal to 90 degrees. So that means they're both less than 90 degrees, each one is. Those are called acute angles. They're less than 90 degrees. The sum of two angles, A and B here, they're called complementary. Okay, so A plus B, angle A plus angle B, has to be equal to 90 degrees. So that, again, that means they are complementary. Now the complementary angle theorem says that cofunctions of complementary angles are equal. Well, to understand that, we need to understand two things. We need to understand what cofunctions are, and we need to understand what complementary angles are. Well, complementary angles, that's pretty easy to understand. But what are cofunctions? Well, let's think about the trig functions, just the way that we pronounce them. We have a sine function, and we have a cosine function. We have a secant function, and we have a cosecant function. We have a tangent function, and we have a cotangent function. So sine and cosine are cofunctions. Tangent and cotangent are cofunctions. Secant and cosecant are cofunctions. So what does that mean? That means that if we add two angle measures together for those two functions and we get 90 degrees, then the value you get out for each of those cofunctions is equal. For example, the sine of 30 degrees is equal to the cosine of 60 degrees because they're cofunctions, and 30 plus 60 is 90. Right? The sine of 30 degrees is 1/2. The cosine of 60 degrees is 1/2. Well, even if I don't know what they're equal to, if they add up to be 90, then those are equal. For example, the tangent of 12 degrees must be equal to the cotangent of 78 degrees, because 12 plus 78 is 90. And that's always true. So if those add up to be 90, then they're equal. Well, you could use that to change one trig function, one cofunction, into its other cofunction. For example, what if I had the cosecant of 15 degrees minus the secant of 75 degrees. Then cosecant of 15 is the same thing as the secant of 75, right? Because they're cofunctions, and those angles add up to be 90 degrees. So by changing cosecant into secant, now you see this is something subtracted from itself. So that's 0. We don't even have to know what those angle measures are equal to, and we're able to manipulate them and work out the problem. So let's say that I had sine squared of 1 degree plus cosine squared of 89 degrees. I'm sorry, let's change that to sine squared. Change that second one to sine squared. So let's say I have sine squared of 1 degree plus sine squared of 89 degrees. Then I can change either one of those over to its cofunction. I'll just choose the first one. Sine squared of 1 degree is the same thing as cosine squared of 89 degrees. And so if I have cosine squared of some degree plus sine squared of that same degree, then by the Pythagorean identity, what does that equal to? 1. Right? The Pythagorean identity is sine squared theta plus cosine squared theta equals 1. As long as these angle measures are the same, that's always equal to 1. So just by changing sine squared of 1 degree into its cofunction, I'm able to work the problem without knowing what the sine or cosine of 89 degrees is equal to. Alright, let's look at another. Let's say that I had the cosine of 40 degrees over the sine of 50 degrees. Now you can change either one of those into its cofunction. I'm just going to change the numerator into its cofunction, just out of necessity, or just because it's easy. Alright, so cosine, I want to change it to sine. What plus 40 degrees is 90 degrees? 50. So the cosine of 40 degrees is the same thing as the sine of 50 degrees. Well, the denominator in this problem is sine of 50 degrees. So something divided by itself. It's 1.